Question number 12, exercise 7.11. So we have to integrate 0 to pi x dx over 1 plus sin x. So solution 12, I equal to integrating 0 to pi x dx over 1 plus sin x. So here we will be applying P4 property, and that is question number 1. So I equal to, you can write here also, I equal to integration from 0 to pi, integrating from 0 to pi, pi minus x over 1 plus sine pi minus x dx. Why? Because integration of 0 to a fx dx is the same as integration of 0 to a f of a minus x dx. So what is our a here? It is pi. So this will give us, therefore we can say that I equal to, therefore I equal to integration from 0 to pi. This will give us pi minus x over 1 plus sin x. Why? Because sin pi minus is same as sin x. And let this be question number 2. I will add 1 and 2, adding 1 and 2, adding 1 and 2, we have. So what we'll have on adding 1 and 2? Let us expand this one. So adding 1 and 2, where is our 1? Here it is. So adding 1 and 2 we have, let us write it here. So we'll be getting 2i equal to integrating from 0 to pi. Limit is same, we can add the function inside, also denominator same. So this can be written as pi minus x plus x over 1 plus sin x and dx. So minus x plus x cancel each other. We get 2i equal to integrating from 0 to pi, and this pi you can take out. So inside we will be getting 1 over 1 plus sin x, and this dx is here. So now let us multiply and divide by 1 minus sin x. So we will be getting 2i equal to pi into integrating from 0 to pi 1 minus sin x over 1 plus sin x into 1 minus sin x dx. So we'll get, therefore 2i equal to pi into integrating from 0 to pi 1 minus sin x over 1 plus sin x into 1 minus sin x, that is a plus b into a minus b. So it is a square minus b square. So 1 square minus sin square x, that is cos square x. So cos square x dx. I will separate it and see what we get. Therefore we'll get 2i equal to pi into integrating 0 to pi 1 by cos square x, that is sec square x, minus this will give us sin by cos, that is 10x, and 1 cos will still remain and it will become 1 by cos, so it will become sec x, and this will become, so here we'll write dx. Now we'll apply the limit. Therefore we can see that 2i equal to pi into, first let us integrate this. Integration of sec square is 10x, minus here we'll get sec x, and limits are from 0 to pi. So we'll be putting the limit now. So we'll get, therefore 2i equal to pi into, first we'll put the upper limit, that is 10 pi minus sec pi minus tan 0 and minus sec 0. So therefore we'll get 2i equal to pi into 10 pi is 0 minus, but sec pi is minus 1, minus here also we'll be getting tan 0 is 0 and minus sec 0 is 1. So therefore we get 2i equal to pi into, this is minus minus plus, so plus 1, and here also 1 plus 1. So we'll get, therefore 2i equal to 2 pi, and 2 and 2 cancelled out. So we'll get, therefore I equal to pi. So this is the answer of question number 12. Question number 13 now, exercise 7.11. Solution 13, I equal to integration from minus pi by 2 to pi by 2 sine raised to 7 x dx. So here we'll apply property P7 and check whether first part is applicable of that or second part. So first of all, we'll check whether this function is odd or even. Let fx equal to sine raised to 7x. So therefore f of minus x equal to sine raised this can be written as sine minus x raised to 7 equal to, because sine minus x is minus sine x, so we'll be getting minus sine x raised to the power 7 equal to this can be written as minus sine x raised to the power 7. Therefore we can say that f of minus x equal to minus, and this is nothing but fx. So what is this? If we see it carefully, this is fx, so this can be written as here fx. So therefore we can say that f is an odd function. F is an odd function, and therefore what we can say that I equal to 0. Why it is 0? Because if there is a function from if we are integrating minus a to a fx dx, then minus a to a fx dx is equal to 0 if f is an odd function. If f of x equal to minus fx, sorry, if f of minus x equal to minus fx, so this is what an odd function. So here we are getting exactly the same thing, so that means here the value of I will be 0, and this is property number 7 and second part. You can check it out. Question number 14, exercise 7.11. Solution 14, I equal to integrating from 0 to 2 pi cos raised to 5x dx. So these are the form 0 to 2a fx dx. So let us check whether property P6 is applicable in this or not. So we'll check whether f2 of a minus x is same as fx or not. So let fx equal to cos raised to 5x. Therefore f 2 pi minus x equal to cos 2 pi minus x raised to 5, and that is equal to cos x raised to the 5 power. So this means we can say that therefore f of 2 pi minus x is same as fx. Therefore we'll get I equal to, this can be written as 2 into integration of 0 to pi cos raised to 5x dx. Why? Because whenever we are integrating 0 to 2a fx dx, then it is equal to 2 into integration from 0 to a fx dx if f of 2a minus x is same as fx, so which is the case here. So now we'll simplify this further. So what we'll be solving this portion, we'll try to obtain the value of I. Let this be say 1. So therefore from 1 we have, so what we are having, I equal to 2 into integration from 0 to pi, this can be written as cos x into cos raised to 4x dx, and I equal to 2 into integrating from 0 to pi cos x, and this can be written as cos square x square and here dx. Why we are writing this way? Because we know that the differentiation of sine is cos, so we can write this cos square in terms of sine. I equal to integration from 0 to pi is equal to, so and here, yes, this is 2 actually, not equal to, this 2 is here, so here 2 we have missed, so that 2 will come here. 0 to pi cos x, and this is 1 minus sine square x, and whole square, and this will become dx. So now uh, let us substitute sin x as t, so let sin x equal to t, therefore we will get cos x dx equal to dt. Now we know that whenever we are doing substitution we have to change the limits also, so let us do the changes. So when x is equal to 0, when x equal, because we are here we are integrating in terms of x, so the limit also will be in terms of x only. So x equal to 0, this implies t equal to, just we put in this sine 0, that is 0, and when x equal to pi, this implies t equal to sine pi, and sine pi we know is equal to 0. Therefore I equal to 2, integrating from 0 to 0, and this will become 1 minus sine square x, so it will become 1 minus t square whole square, and cos x dx is dt. And we know that whenever we integrate function from a to a, its answer is 0, so the answer of this will be equal to 0. Therefore I equal to 0 is the answer of question number 14. Question number 15 will be for self trial. You'll try on your own, and in this the property which you can apply is apply P4 property, and definitely you will be getting the answer for this. So question number 15 will be for your self trial, you'll do on your own. Question number 16, exercise 7.11, integrating log 1 plus cos x dx from 0 to pi. So let us solve this 16th one. Solution 16, I equal to integrating 0 to pi log 1 plus cos x dx. So it's a question of lot of computation, so we'll be doing here, and what we'll be getting here is suppose this is 1. Now we'll apply in this property P4, so we'll be getting also I equal to integrating 0 to pi, and this will become log, and we can rewrite it as 1 plus cos pi minus x, and here dx. So this will give us, therefore I equal to integrating 0 to pi log 1 plus cos pi minus x, we know that is minus cos x, so we can write this as log of 1 minus cos x dx, and this will give us suppose this is 2. Now let us add 1 and 2, adding 1 and 2, adding 1 and 2 we have. So let us see what we have on adding 1 and 2. We'll be getting 2i equal to I plus I is 2i, and limits are same, so we can add these two functions. So we'll be getting, now we know that log a plus log is log a into b, so this will give us log 1 plus cos x into 1 minus cos x, and this is dx here. So this will give us, therefore 2i equal to integrating 0 to pi, and we know that log we know that 1 plus cos x into 1 minus cos x is 1 minus cos square x, and that is sine square x, so this we can write as log sine square x and dx. And we know that whenever any function is having power inside the log, that power can come out, so with this can be written as 2i equal to 0 to pi, this 2 can be coming out of the logarithm function, and the constant, so it can come out the integration also. So we will write here log sine x dx, so both side 2 will be cancelled out, and suppose let this be question number 3. Now I equal to, this we can write as so what we are having, I equal to 0 to pi log sine x dx. Now in this, if we apply P4, it will be of not any help to us, so we'll be applying the property P6. So for applying that one, we'll be getting I equal to 2 into integration of 0 to pi by 2 log sine x dx. Why? Because sine x is same as sine pi minus x, so we can apply here p6, and by applying p6 the limits are changing, otherwise the limits are remaining the same. If you apply p4 there is no change in this at all, so it will be of no help to us. So this is why we have applied p6. Now suppose this is fourth one, so now we'll be applying in this p4 also I equal to, we can write this as 2 integrating from 0 to pi by 2 log, here we can replace sin x with sin pi by 2 minus x, sin pi by 2 minus x dx. So this will give us, therefore I equal to 2 integrating 0 to pi by 2, this will become log cos x dx. And now let us add 4 and 5. Adding 4 and 5 we have, so let us add them and see what we get on adding them. So we'll be getting, therefore 2I equal to 2 integrating from 0 to pi by 2, and we know that log a plus log b is log a into b, so this will give us log sin x into cos x, and here we will write dx. Now we'll cancel to both side, and we'll be getting so therefore we will be getting I equal to integrating from 0 to pi by 2 log sin x cos x dx. So we can reduce this by multiplying and dividing with 2 inside the log function. So we can rewrite this as I equal to 0 to pi by 2 log 2 sin x cos x by 2 dx. Therefore I equal to integrating 0 to pi by 2, this will become log sin 2x and minus log 2 dx. So this one we can write as, therefore I equal to integrating 0 to pi by 2 log sin 2x dx minus this will be integrating 0 to pi by 2 log 2 dx, separating them, and this will give us, therefore I equal to integrating 0 to pi by 2 log sin 2x dx, and this will become minus log 2, and integration of 1 is x, so we can write here x and put limit as 0 to pi by 2. So this will give us, therefore I equal to, suppose this is our I1, so I1 minus log 2 into, this will become pi by 2, and suppose this is our equation number, say 4, 5 are over, so we'll take it as equation number 6. So this is equation number 6. Now we'll be solving I1. If you know the value of I1, we can get the answer of this one. So we'll solve I1. So what is I1? I1 equal to, let us see from here, 0 to pi by 2 log sin 2x dx. 0 to pi by 2 log sin 2x dx. Yes. So now we'll try to take the help, we will try to convert this in this form, which one form which we have already here, that is let us see here, yes, in the form of equation number 3. Let us check whether we can do this or not. So for that, here we'll do some changes. We'll take sin 2x as t. Why? Because if we see equation number 3, sine is a function of x, not 2x, and also the limits are from 0 to pi, so the change we'll do, we'll take 2x as t, so let 2x equal to t, therefore we'll get dx equal to dt by 2, and also we'll have to change the limit, so when x is equal to 0, this implies t equal to 2 into 0, that is 0, and when x equal to pi by 2, this implies t equal to 2 into x, that is 2 into pi by 2, and that is pi. So therefore we can say that I1 is equal to integration from 0 to pi log, and sine is there already 2x we have taken as t sine t, and here we have having dt by 2, so equal to half integration from 0 to pi log sine t dt, and therefore I1 equal to, and we know that in definite integral if you change the variable, it doesn't make any difference, it is still the same. So I1 can be written as half 0 to pi. Our function is in terms of, we have to integrate in terms of x, so we'll convert this in terms of x, so log sine x dx, and the reason being that already discussed, because integrating a to b fx dx is same as integrating a to b fy dy. There is no change if it is definite integral. So we'll write here fy. So now let us move to previous page, and we can see in that, let us move in this one. Here we can see, yes, I equal to integration 0 to pi log sin x dx. There's integration of 0 to pi log sin x dx is same as I, and that is what we are getting here also, 0 to pi log sin x dx. So we can write this as therefore I1 equal to half log I, and that is using third one. Let this be equation number 7. So we'll be writing putting 7 in, putting 7 in, putting 7 in. So previous page we are going in that, we'll see, so we'll put in 6. So putting 7 in 6, we have, so let us do this portion there only. So here I equal to, yes, so do the correction, this will become I, not I1, because I1, if I1 is equal to I1, it will be cancelled out. This is I only, and this we have taken as, when we worked out this, we have taken as I1 to reduce our work. So what we have got is, therefore, or let us move back in that only, it will be easier, it will be right also. So we are getting I equal to, what is it, I1, in place of I1 we write half, and how we got here log I, this is not log I, sorry, this is half I, because this whole is equal to, this we have taken, this whole is equal to I, we have seen in third one, so this is half I. So I equal to half I, and minus log 2 pi by 2, minus pi by 2 log 2. Let us see whether we have written correctly or not. I equal to I1 is I by 2 minus log 2 into pi by 2. So we should have I equal to I by 2 minus pi by 2 log 2. Yes, it's correct. So now let us simplify this further. So we'll be getting, therefore uh, I minus half I equal to minus pi by 2 log 2, and this will give us, so we'll be getting half I equal to minus pi by 2 log 2. So therefore we'll be getting this one as uh, half, and half can be cancelled out, we'll be getting I equal to minus pi log 2. So this is the answer of question number 16. So with this, question number 16 is complete. Question number 19, exercise 7.11. So solving 19th one, I equal to integration of 0 to a fx gx dx, and we have, suppose this is 1, and what we are having is f of x is same as f of a minus x, and gx is equal to 4 minus uh, 4 minus g of a minus x, and let this be 2. So putting 2 in 1, we have, so what we'll have on putting 2 in 1, so we have I equal to integrating from 0 to a. In place of fx we'll be writing there f of a minus x, and in place of gx we'll write 4 minus g of a minus x, and this is dx. So this can be written as I equal to integration of 0 to a f of a minus x, and 4 is there, so 4 we can write here, dx minus integration of 0 to a f of a minus x. So this will be g of a minus x dx, and we can rewrite this as I equal to 4 integration of 0 to a, and it has been given to us f of a minus x is fx, so we write here fx dx, and minus 0 to a, and what we can do is now we can use property P4, in that we know that if we replace x with a minus x, it will not make any difference. So we can write this f of a minus, in place of x let us write a minus x, and g a minus, in place of x we'll write a minus x, and this is dx. So applying, actually we are applying, what we are doing here is applying P4 only in this part. So applying this P4, property P4 we are applying. So now we'll be getting here, therefore I equal to 4 0 to a fx dx minus 0 to a, and this can be written as, simplifying it, will be getting a minus a, this plus fx, and multiplied by this will also become gx and dx. And if we see that our, from equation number 1, this is equal to I, so we can write this as, therefore I equal to 4 times 0 to a fx dx, here also dx, minus I. And here it will be better if you mention the property. So the property P4 you write here, write property P4, so that will be better. So property P4 that we have to write here, let us write down, because integration of 0 to a fx dx is same as 0 to a f of a minus x dx. So that property we have applied here in second part. Now simplifying this further, we'll be getting, therefore 2I equal to 4 times 0 to a fx dx. So this will give us, therefore I equal to 2 times of 0 to a fx dx. Now moving back to our equation number 1, I we can replace with 0 to a fx dx. So that is what we write. Therefore integration of 0 to a fx gx dx is equal to 2 times of 0 to a fx dx. So this is the solution of question number 19. So with this, question number 19 is complete, and let us see whether yes, we have got the same thing as required, 2 times of 0 to a fx dx. Now so this all is complete, and some questions for self trial I will be giving to you. Self trial now. Self trial. So whatever questions are remaining questions will be all for self trial. Remaining questions for self trial. For self trial. So that means you will try them on your own, and with this the chapter is complete. Chapter is complete. You can try the miscellaneous exercise on your own. They are not difficult. Just apply the concept which you have learned throughout the chapter, and you will be able to solve them. So with this the chapter is complete.